055, Mayday, Mayday, Mayday.
Today, many systems are used for the operation of engines, especially internal combustion engines, gas turbine engines and rocket engines. In fact, these systems come together to help engines run safely and efficiently. The system we will examine in this video is the fuel systems required for the operation of all engines using fossil fuels. The fact that the fuel is easily ignited by its nature makes it much more dangerous than other fluids used in the engine. For this reason, the most important and basic task of the fuel systems used in aircraft is to ensure that the appropriate amount of fuel is delivered to the combustion chamber in a safe and appropriate amount. Engine fuel systems in all aircraft generally have 5 purposes. These are increasing the pressure of the fuel taken from the aircraft fuel system, heating, adjusting, filtering and sending it to the fuel nozzles. Adjusting the fuel in aircrafts actually works in a similar way to pressing the accelerator pedal in our cars. As it is known, to the extent that we press the gas pedal in our car, fuel is sent to the engine combustion system and our car accelerates. In aircrafts, although the pilot manages the engine fuel system by controlling a throttle lever, much more complex and complicated systems are used to fulfill this task. The extraordinary atmospheric conditions that aircraft encounter in the air require much more precise and controlled operation of aircraft fuel systems compared to automobiles. It even necessitates the production of fluids such as oil and fuel used in engines under special conditions. Today I will try to explain the CFM56-7 engine fuel system, which is widely used in the world of aircraft engine fuel systems. In the fuel system of a typical CFM56 engine, the first unit in which the fuel from the aircraft fuel system enters the engine is the engine fuel pump. The fuel pump is attached to the rear of the gearbox and works with the mechanical power it receives from it. There are 2 pressure elements and 2 filters in the fuel pump as low and high pressure. The main task of the fuel pump is to supply pressurized fuel to the HMU, that is, to the servo and measurement sections of the hydromechanical unit, as well as to the fuel nozzles. At the same time, the fuel filters on the pump undertake the task of cleaning the fuel going to the HMU. The oil fuel coolers in the fuel system are the common units of the oil and fuel systems. As a mechanical unit, the HMU send fuel adjusted to the combustion chamber and servo fuel system according to the reference information it receives from the EEC and throttle. In addition, when the throttle lever is turned off and the fire extinguisher handle is activated, the fuel going to the combustion chamber is stopped by the high-pressure shut-off valve in the HMU. Fuel flow transmitter, on the other hand, is a unit that measures the amount of fuel passing through it. The task of the fuel nozzle filter, which is another unit of the system, is to clean the fuel by filtering it, as in other filters. The last part of our fuel system is the fuel nozzles. Fuel nozzles are responsible for ensuring proper and efficient combustion by atomizing the adjusted fuel coming through the manifolds into the combustion chamber. After briefly recognizing the parts of the fuel system, let's take a closer look at the operation of the system from the table. The fuel coming from the aircraft fuel system, that is, the main and wing tanks, is taken to the engine fuel system by the engine fuel pump. The fuel taken into the pump is first pressurized by the centrifugal flow low-pressure pump element. The pressurized fuel then goes to the IDG integrated drive generator oil cooler, then to the main oil fuel heat exchanger unit. The oil and fuel circulating in these 2 units exchange heat without physical contact with each other. According to the laws of thermodynamics, hot oil transfers its heat to the fuel, that is, it cools. What is systematically desired here is to reach the ideal combustion temperature of the fuel, which is quite cold, that is, to ensure easy and efficient combustion. Another task of the oil fuel cooler is to melt the frozen water particles in the cold fuel coming from the aircraft fuel tanks at high altitudes. In fact, the fuel contains an acceptable amount of water and this situation does not have a negative effect on combustion, but since the ice particles are solid, they can clog the filters and cause malfunctions in the system. For these reasons, it is necessary to melt the possible ice particles in the fuel by heating it. The purpose of cooling the oil is to preserve the amount and properties of the oil. The oil circulating in the engine oil system and aircraft generator gets extremely hot due to reasons such as circulating in areas close to the hot areas of the engine and being used to cool the bearing parts that rub against each other. If the heated oil is not cooled, it evaporates and is thrown into the atmosphere from the oil tanks, and therefore oil consumption increases. In addition, the oil begins to lose its effective lubricating properties due to overheating. In order to prevent these negative situations, aeronautical engineers have succeeded in eliminating these problems with the heat transfer between these two fluids. The fuel, which continues on its way in the system passing through the oil-fuel coolers, comes to the filters in order to be purified from the foreign substances in it. Filters filter the organic and metal particles that come with the fuel, allowing a cleaner fuel to go to the mechanical systems. If for any reason, the fuel filter starts to get dirty, a warning light may come on in the cockpit on some aircraft models. When the filter is completely dirty, a bypass valve in the fuel filter body opens and sends the fuel to the high-pressure pump element without being filtered. The fuel pressure, which is further increased in the gear-type high-pressure pump, is sent to the hydromechanical unit. The servo washer filter inside the fuel pump cleans the fuel going to the HMU servo section. In case the filter is clogged, a bypass valve at the filter outlet opens, allowing the fuel to go to the servo system without being filtered. The servo fuel heater heats the fuel going to the servo system from the hydromechanical unit. Servo fuel heater provides the cooling of the oil returning to the tank by finishing the drain oil, that is, the lubrication task throughout the engine. The other part of the fuel coming out of the high-pressure pump is firstly sent to the fuel metering valve by the hydromechanical unit and then to the fuel flow transmitter after being adjusted at the required rate. Then, the fuel is filtered again in the fuel nozzle filter and sent into the combustion chamber, that is, to the fuel nozzles. The hydromechanical unit also provides fuel for the operation of the engine servo system. Servo systems have no direct relationship with the combustion systems of the engine. When it comes to the servo units of the engine, the valves that open and close with the fuel pressure in various parts of the engine should come to mind. The hydromechanical unit performs many tasks by receiving fuel measurement signals from EEC and aircraft with throttle movements. The fuel pump always supplies the HMU with more fuel than it can use. The fuel that the HMU does not use, bypass fuel, returns to the integrated drive generator, IDG, oil cooler outlet and then through the oil/fuel heat exchanger back to the fuel pump. The fuel flow transmitter provides the correct fuel planning by sending the amount of fuel consumed in the system to the EEC with electrical signals. In addition, this information informs the pilot about the use of engine fuel in the cockpit. Then the fuel goes through the fuel nozzle filter to the fuel nozzles. Fuel is transported to the fuel nozzles by steel fuel manifolds. Fuel nozzles, on the other hand, provide efficient continuation of combustion by providing atomized fuel to the engine combustion chamber. Also, hydromechanical unit provides fuel flow control to units such as fuel metering valve, transient bleed valve, high-pressure turbine active clearance control valve, low-pressure turbine active clearance control valve, variable bleed valves, variable stator vanes. I just tried to explain the operation of the fuel systems of the CFM56 engine by simplifying it. Many different types of fuel systems and systems containing different parts are used in the field of aviation. It is clear that understanding these complex systems will provide great convenience to both pilots and technicians in terms of understanding how the engine works, as well as finding and fixing possible malfunctions. Aircraft engine fuel system parts are generally similar and perform the same tasks. I hope you can understand the subject in the light of the information I have given. If you like my video, don't forget to subscribe to my channel and click like. See you in new videos.
Midway Tower, Aircoup 99055, Mayday, Mayday, Mayday.